stuff. Kind of standing up and teaching is like not going on as much. Okay, so I think I'm doing that now, Allie. So here we go. Okay, so back to the notes where we left off. I told you there was a problem just like this in the quiz. Okay, can you guys, Allie, Kara, Mason, can you guys see the notes now?
Yeah, we can.
Okay, good. So this is working. Okay, so I went through, and I'm not going to do it again, but yesterday in the lesson, I went through and I did this problem. And I wanted to see if you guys had any questions on that problem. And then I wanted to just to talk briefly about, there's one just like this on the quiz. And I'll tell you, there's one like this on the test too. I did make up the test like I told you. I was going to wait to see if it was hybrid or not, and now we know that it is. And so I know you're going to be here, which to me is way better. And so I've got the test made up, and I made up a problem just like this. So are we okay on this one?
I have one question, Mr. Wood.
Yeah, Mason.
So when you're going through the steps, it says on step 3, which is like warm the liquid to 100 degrees C.
Yeah.
How do we determine the temperature to warm the ice to like water?
You know, if it's water, and this is where, and Mason, that is a really good question. You know, if you look on the diagram, the graph, notice where it's ice water. Notice, go over to the y-axis. Look at the temperature there. It's 0. And then go up to where it's in green, where it's water, steam, and go over to again to the y-axis. It's 100. That's how I know the temperature change. And I'll tell you, the one that's on the quiz is water, and the one that's on the test is water as well.
So if it's water, should we just always assume it would go to water at 100 degrees C?
We're going to go from 0 to 100. Yep.
Okay,
yep,
perfect.
you're right. Good question. Anything else on that problem? Okay, and I'll just tell you for the sake, on number 4 on the quiz, it's a similar kind of problem. And like I said, there is one like this on the test, so you want to make sure you can do it. The answer comes out to be, I had 56.0 kilojoules. And again, on Monday, Tuesday, when you guys are here, I'll get out the answer key to the quiz, and you guys can check whatever you want. If you want to check stuff, you can. So, okay, so definitely on the test, you want to make sure you can do problems like that. Again, number 4 on the quiz, 56.0 kilojoules. Okay, I'm going to go on to the final thing in the chapter then. Are we okay? Okay, I'm not hearing anything. Okay, so here is the next thing, and I'm going to sketch some stuff here on the board with this. But I'm going to give you a minute, and I'm going to go back to the board and kind of sketch some stuff here on the board. One thing that's good on this diagram to notice too is what's on each axis. So we have temperature, and we have temperature on the x-axis, pressure on the y-axis. Okay. And again, I'm going to kind of come back to the board here, but phase change diagram, and this reminded me of something I wanted to get. So while you guys are copying this now. Getting out my vacuum pump here. Okay, I want to, I'm going to just stop this here for a second, and I'm going to just go to the board. Okay. Okay, you guys can see me now? We're back?
Yes.
You see me?
Yes.
Okay. Okay, so what I'm going to do now, and I want to talk about this diagram, but I said I was going to do this. I've got my vacuum pump here. And I'll move this screen down so you guys can see it a little bit. But one thing I'm going to try and do is I'm going to try and boil ice water. I'm going to try and boil ice water, but I'm also just going to put a piece of ice in here. And again, you guys are going to kind of have to believe me. And then I'm also going to put just a piece of ice. So I got one piece of ice here in my vacuum pump, and then I got one piece of ice here I'm just going to put on the desktop. Now I've got some ice water. And the temperature of the ice water right now is about 13 degrees Celsius. Okay, I told you the other day I was going to try and boil ice water, so I'm going to try and do that. Oops, I'm going to have to use my big belcher. So what this is called a vacuum pump. And so what it does, here and I'll show you, this is going to remove all the air from inside here, and it just kind of chugs away. So I'm going to turn it on, and right now, I'm a weakling. I'm not as strong as most of you guys, but I can lift this off because it's heavy, but right now there's air inside here and there's air outside here, so I can lift it off. Well, if I turn this on, always helps when you plug things in. Plug this in. Okay, now I'll turn it on. Okay, and you'll hear it chug. Well, what it's doing is it is removing air from inside of here. And so what happens then is it creates kind of a little vacuum. That's why they call it a vacuum pump. And so what happens then, the amount of the air inside is going down, but the air pressure out here is remaining the same. So now if I turn this off and I try and lift it off, I can't. Not because it's being sucked in, but because air pressure is pushing it in. Air pressure is pushing this in, and so I can't lift it off. Now, if I let the air back in, so if I open this up and I let the air in, and you can't even hear it. There's so little air. Okay, so now what I'm going to do is I'm going to try and get the the water to boil. Okay, so I'm going to turn this back on, and I'm just going to let it go, and I'm going to talk for a second, and we'll come back to this. Now the principle here, as we said in class on Tuesday, we said for water to boil, the air pressure over the liquid had to equal the vapor pressure of the liquid. And how that's recognized is by small little bubbles. And when you get to that point where the air pressure equals the vapor pressure, those little bubbles aren't squashed. But before that point, they are. So we're going to see if this is boiling. So I'm trying to boil water here without heating it. Okay, while we're waiting on that, I'm going to go over here to this side of the board, and I want to just talk about this. This is on the quiz, and I want to look on it at it on the quiz, but it's not on the test. So here's this. It's called a triple point diagram. Okay, so I'm over here. Okay, so I'm just going to move this a little bit. So I'm over here. Okay, so what we've got is we've got pressure, we got temperature. Okay, and then it looks like this, and there's a couple points on the graph. Okay, and then this looks like so. And so here are different points on the graph that you might want to note. Okay, so the first point on the graph is called and first of all, too, note what's being graphed, pressure and temperature. Okay, so I'm going to use
Mr. Wood, would you be able to move it up just a little bit?
Yeah. How's that, Carrie?
Perfect. Thank you.
Okay, thank you for saying that. That's the kind of thing I need help with. Okay, so here are the different locations on the graph that you need to know. This and what we've got here, these are the states. This is, I'm going to write this in red, try to do some colors here. So this is solid, this is liquid, this is gas, solid, liquid, gas. So when we go from solid to liquid, this right here is called the melting curve. And that makes sense because that's where we go solid to liquid. So this whole section right here is the melting curve. Okay, the next thing is the boiling curve. And the boiling curve is when we go liquid to gas. So that would be right here. That would be the boiling curve. Okay, and the next section is called the sublimation curve. So that would be here to here. And again, that's where we go solid to gas. Now, and then the reason they call this the triple point is that is this point right here. And a matter of fact, in here right now, where I put the ice cube, that's at the triple point because there's solid, but there's a little bit of melting going on, and there's a little bit of vapor. So right in the vacuum pump right now is the triple point. And if you look at that, the pressure is really, really low. If you look at the value back in the notes, I think I have it as 0.0060, and the temperature is also really low, 0.0098. Okay, so here's point one, the melting point, the melting curve. Point two, the boiling curve. Point three is the sublimation curve. Point four is the triple point. Okay, and again, why they call that the triple point is because it's got solid, liquid, and gas in it. Okay, point 5 is called the critical point, and that's up here. And I'm going to show you on the next slide the critical point, just like I've got in the notes. The critical point is where fluid forms. The temperature is, I'm just reading right off my notes, the temperature is too high to be a liquid, the pressure is too high to be a gas. It's a supercritical fluid. Okay, and then a couple other points, and I've got these labeled on the graph itself, actually. Right here at a pressure of 1. So a pressure of 1. Right here, that is the melting point. So here's point 6 is the melting point. and melting point where it goes solid to liquid, we're at a little bit pressure of less than 1. And then if I go over here, here would be 0.7. This is the boiling point. And this is one of those things, I'm going to tell you, this is going to be on our quiz. It's on our quiz, and we can look at this. And again, that's why I want to leave some time for questions on Monday and Tuesday. But if you look on the quiz, I think it is question number 6, and it's really not too bad. It's kind of like reading a graph. But here are the important points again. A lot of lines here, but the melting curve right here, 0.1. The boiling curve here going liquid to gas, 2. 3, the sublimation curve going from solid to gas. Number 4 is the triple point. I actually have that right now in the vacuum pump. That's where we have solid, liquid, gas. And again, I'm going to come back to the notes here in a second, but that's where we have, again, we have low pressure and really low temperature. The melting temperature is so this pressure where it converts from a solid to a liquid, and then the boiling temperature right here. Okay, so those are key things. Now, one thing about this, and I'm going to show you, I think it's CO2 next. Water is the only one that the line angles up like this. Everything else is like this, because if we look at this, if the pressure goes up, that means the volume goes down. And if the volume goes down, that means the density goes up. So here, when we go up, that's what happens with water. So as the pressure goes up, the volume goes down, so the density goes up. And that's actually why water has a density where the liquid actually floats on the. But anyways, those are key things on the graph. Now, one thing right now, I put ice in both the vacuum pumps, so the pressure went down. So it's not. So what I'm saying is, so what I've done, and again, you can't see it. But this was ice in the vacuum pump, so it went here. So it didn't melt as much. It melted some because of the temperature. But the ice that I put on the tabletop would have went this way, and there's a bigger puddle. And I know you guys can't see this. But anyways, that's kind of the key things on the graph. Now, if I come back here, okay, I said the whole point of this was to get the ice water to boil. And I don't know, can you guys see this? Mason and Kara, can you see?
Yes, we can.
So it's boiling. Would you agree it's boiling? Can you see bubbles forming in there?
Yes.
And again, it's hard in a Google Meet, but it is boiling. So, okay. So if I ask you, is it possible to get water to boil without heating it? The answer is yeah. If you can lower the pressure over it, you can. Okay. And now the final thing. So now I'm gonna see a couple things, I guess. I'm going to see the temperature of the water. And we're used to having water when we boil it for the temperature to go up. Remember, it was like 8 degrees, I said? Okay, so we're going to see the temperature now. Okay, so now I'm going to do this, and that ice cube is melting. But if I look at the temperature now, I think the temperature is actually going to go down, and it did. It didn't go down a lot. It's like 6 degrees, but it did go down a little bit. Why did that happen? Well, that happened because the molecules that were boiling away were the faster ones, leaving the colder ones behind. Now, there is some puddles up here, and again, you guys can't see it in a Google Meet. But there's not as big a puddles in here with the ice cube as there is over here. I've got quite a mess over here. And that's what I was trying to explain on the triple point diagram. When I put the ice in the vacuum pump, the temperature went up, but the pressure went down, so it stayed more solid. So the pressure went down, the temperature went up. But the ice that I put just out here, it went this way, and there's a much bigger puddle over here. And again, it's really not a great thing to do in a Google Meet, but things that can be explained with this diagram. Okay, so let me come back to my notes. Okay, so I'm going to come back here, finish this chapter up. Okay, so back to the notes. Again, doing this in a Google Meet isn't the best, but a couple other things you can explain on this is how a pressure cooker works. If your parents might use a pressure cooker when they cook, it's what it does is you capture the you don't let the gas escape. So what happens is the pressure builds up. Well, when the pressure builds up, that means we go up the melting curve. And so what we can do is we can cook at a higher temperature. Every 10 degrees higher the temperature is raised, cuts the cooking time in half. But anyways, there's another thing on here I always think is kind of interesting is ice skating. So if you think of ice, so if you're right at the one pressure, the pressure one, when you push down, you increase the pressure. And what that does then, if you go straight up, then it becomes liquid. And so like the avalanche, when they're out there playing hockey or anybody, you go ice skating, you're increasing the pressure. What you're doing on the ice skate, you're making it become a film of water. And it's harder to walk on ice. You can skate faster with a little film of water. It's harder to walk on ice with a layer of water. Skates will skate faster, become more slippery. Okay, and then here's so we've talked about this. Here, the next slide. This is CO2, and again, this is where most everything else would be with the melting curve being a slope like that. Okay, and so again, it's the same exact graph. And the pictures above is the critical point. Okay, here, and this kind of explains pressure at which ice falls or changes to water, but where the density of the ice actually decreases is what this is explaining. So phase change of water with a negative slope. So that red line is very unique to water. Okay, and then the final thing in this chapter, I just want to spend a minute on this. I'd always find this kind of fascinating that just about water, all the different things with water, but it exists in 3 states. And again, if you were to go any place else in the solar system, there's one place that they think there's water, and it's ice. It's the moon of Jupiter called Europa. So water makes the Earth very unique, but it exists in 3 different states. Solid, we know this, solid, gas, liquid. Doesn't do this anywhere else in our solar system. Among liquids, water is unique. It has low molar mass, yet it is a liquid at room temperature. Compare that to the other main group halides. So what I'm talking about is the main group. So if we're looking at oxygen, fluorine, nitrogen, elements in the same row with hydrogen. And if you look there, water is really unique. It doesn't follow the pattern at all. No other substance of similar molar mass comes close to being a liquid at room temperature. This is due to water being bent and significant polarity. Number 3, because of water's high polarity, it allows it to dissolve many other compounds. Like dissolves likes, even a number of nonpolar gases such as O2 and CO2. Remember the induced dipole we talked about back at the beginning of this chapter, because water is so strongly polar. Okay, and then this is the last one in the chapter. Water is the main solvent within living organisms, within us. Water is also the main solvent in our environment. It allows aquatic animals to survive by breathing O2 and allowing aquatic plants to survive by dissolving CO2. And then here, water has a high specific heat. What does this mean? This means that the entire Earth, 2/3 of the Earth, means the temperature is very consistent. It doesn't fluctuate. Without water, the temperature may fluctuate like it does on Mars. Like on Mars, it gets incredibly hot and incredibly cold. But because we have so much water on Earth, that doesn't happen. And then the density, which I was just talking about, it decreases when freezing occurs. This causes ice to float. Ice acts as an insulator, which helps to preserve life. So water is definitely a unique thing, and I always kind of think it's pretty cool to talk about it. Okay, so what I want to do now, so we are now done with chapter 10. Okay, the last thing I want to do today is I want to review and talk about the test. A couple have asked about here just a second. A couple have asked about, because we've got 3 chapters here, and to kind of go down on the number of problems that we've got here. So let me, just one second here. So I want to go over the topics for the test, because what I want you guys working on tomorrow and when I see you guys again is getting yourself ready for the test, working on the quiz. And again, you're probably done with Tinker Toys, but you could work on the Tinker Toys as well. Okay, so let me present this to you. And again, this will specify a little bit what the problems in the different chapters that you should look at in preparing for the test. Okay, so this is my little handwritten thing. And I posted this on both my website and on Canvas, and so you can look at this. But this test is going to be chapters 8 through 10. It is going to be, again, a test that when you guys get here, we're going to need to get going on Wednesday, Thursday. So from chapter 8, here are things that you guys need to know how to do, or dots. Definitely know how to do dots. There's a question or two about lattice energy Coulombic attraction. So we talked about the ion size, and we talked about the difference in charge. Okay, formal charges, not a major thing on the test. I think there's one question about formal charges, so you need to know that. Bond length, bond type, bond energy. So I'm talking there about single bonds, double bonds, triple bonds. Single bonds, double bonds, triple bonds. Okay, and we said, okay, a double bond is shorter, but it's not half as short, and it's stronger, but it's not twice as strong. A triple bond, again, is shorter and stronger, but it's not a third as short, and it's not 3 times as strong, okay? Definitely on the test, once or twice, the delta H is equal to reactants minus products. I'll give you a table where you'll have to know how many bonds there are, and you got to be able to do a problem like that. Shapes, you got to know all the shapes. That's one thing you're going to have to memorize, as well as bond angles. Okay, and then polar and nonpolar. If a problem says, does this have a dipole moment, that means that it's polar. So that's the key things from chapter 8. Okay, and I'll slow down here for those that are writing this down. And again, I posted this both on my Canvas page and my website. Okay, and then in chapter 9, the key things is hybridization. So remember, those went right with the families and the electron domains. So we had sp3, sp2, sp, sp3d, sp3d2, and those were connected right to electron domains. And then we talked about multiple bonds. That's where we had unhybridized p. So in a double bond, there's one unhybridized p. In a triple bond, there are 2 unhybridized p. And then sigma and pi bonds, not a major thing on the test, but it'll be on the test again. So remember, sigma bonds are all the single bonds and the first bond in a double or triple bond. The pi bond is always the second bond in a double bond and the second and third bond in a triple bond. And then the chapter that we just got done with, Okay, and again, I'm just going to give you guys a second to write this all down. I'll scroll down. So in chapter 10, intermolecular forces, hydrogen bonds, dipoles, London, and remember how I connected intramolecular forces to intermolecular forces. The concept of polarizability. So the bigger the molecule, the more polarizable it is. Okay, and then solids, and this is going to be on the test just like it's on the quiz, those 5 different types of solids. Okay, and then intermolecular forces and how they're connected. Boiling point, BP, boiling point, MP, melting point, HF, heat of fusion, HV, heat of vaporization, and you can't see it, viscosity up, and surface tension, the arrows should go up. The one that's the opposite is vapor pressure. VP, vapor pressure, goes down. So intermolecular force goes up, vapor pressure goes down. And then there's going to be, again, on vapor pressure, heat of fusion, heat of vaporization, I could ask you to explain. So why does the heat of fusion higher for water than it is a London force? Well, because the strong intermolecular forces, it takes more energy to break that apart. And then I talked about the beginning of class today, phase change diagrams and calculations. Okay, and then I went through the textbook, and here are the problems that you guys should focus in on. Okay, and again, I'll give you a minute to write this down, but this is, again, both on my website and it's on my Canvas page. So there's a lot of things to study. And again, I really wanted to do a test on 8, 9, and then just with this year, we just got to have to keep moving. Our next test will be on 12 and 13, which usually I have a test on 12 and 13 separately, but I'm going to try and just hit the main points on those things to get through as much as we can. Okay, again, so I'm going to, again, you guys can go to my website and see that. Okay, I think it's working for me here. Of course, it works for me today, and then it won't work for me on Monday when I need it to work. Okay, final thing. So this is what you guys should be working on. Again, tomorrow I'm not going to post any lesson. We are going to start chapter 12 next week, but I do want to leave. We're going to spend about a half hour on chapter 12, and then we're going to, I'll just have time for questions. But what you guys can be working on, you have those textbook problems. You have the quiz for chapter 10. Okay, if you're not done with Tinker Toys, you got to get done with that. If you send it to me via email, again, what I want you guys to do is to actually turn it in to me. Just turn it in to me Monday or Tuesday. Other things you can work on is here is the review for chapter 10. I would look at this. And you also, there was 2 reviews for chapter 8, 9. One looked like this. And again, all this is on my Canvas page and my website. And the other one looked like this. So to me, tomorrow, over the weekend, I would be working on all your stuff, getting ready for, getting ready for the test. And then I've explained what we're going to be doing on Monday and Tuesday. We're going to move into 12, but I do want to leave time for questions. And if you need a Google Meet, just send me an email and we can do that. So I am done. Were there questions you guys had for me? Okay, if you don't have any questions, Ethan, question.
I was wondering, on the Tinker Toy Lab,
Yeah.
the very last one, did you want us to do the AB and the shape of each center item as well as height?
I wanted you, Ethan, on that last one, I did not want you to do, what I wanted you to do was to show, if you can you see this? To show the dot structure, but do not worry about anything in here. Do not worry about anything in here. But over here, I do want you to do the ABE, and I want you to do it for nitrogen, oxygen, and the 2 carbons. And then do the shape off the nitrogen, oxygen, and the 2 carbons and the hybridization. So really the only thing you're not doing is this one right here.
Okay.
Does that make sense?
Yeah.
Okay, good. Is there any other questions you guys have? If not, hey, I will see you guys in person Monday or Tuesday, and that'll be a good thing. And we're definitely grind time now in AP Chem because we just got to get through as much as we can to do as well as we can. So I'm done. I will see you guys either in person Monday or Google Meet Monday and in person Tuesday. So see you guys.
Thank you.
Thank you, Mr.
Juliana,
Wood.
where are you at? Brooklyn.
Thank you.
Hi,
Thank you,
Mr.
Mr.
Wood.
Wood.
Turn him up.
Are you guys
Oh,
out in
what did
school?
you do?
Wait, Mr. Wood, hold on. I can't hear you.
Are you out in front of the school?
Yeah.
Yes.
Can you not come in or?
No, we can.
Yeah, we're just giving out t-shirts for Wish Week.
Oh,